Hello and welcome back, everybody. Today in geometry, we are looking at the following section, which is 4.8, 4.9, and there's not really much of a name to it. In fact, it's literally just called writing up proofs. So what that means is we're now going to start literally just writing proof. Take everything that we learned so far with the theorem, postulates, and definitions and put it to good use. So as you can see, we're just going to be doing proofs and proofs and proofs and proofs. Okay, so let's go ahead and get started. Here we go. Here's the first one done. In this picture, what is given is that angle DAB is congruent to angle DCA. Angle DBC is congruent to angle DCB. And I want to prove that ABC the angle is the same thing as ACB the angle. So that's definitely a lot to swallow, but let's go ahead and decipher this. Let me go ahead and use green over here just to kind of decipher what we have. Angle DAB, now let's go ahead and locate it. DAB, oh, I think I made a mistake already. So that is going to be DBA. So let me go ahead and make that quick change over here. So I do apologize for that. So DBA. So DBA is going to be congruent to angle DCA. So I'm saying that this angle is going to be the same as this angle over here. So that's the first part. Now, the second part of the given, we're given that DBC is going to be congruent to DCB. So that means that these two right here are going to be equal to each other or congruent to each other, right? So you can see by marking it up, that gives me a better idea as to what's happening. Well, looking at the picture before I go on, you can definitely see that, hey, if these two angles right here are the same on the top, we can go ahead and call them, maybe like say X over here and X over here. Then these two right here, we can call it Y and Y over here. Then the sum of those two together should definitely be the same thing. And in fact, that's exactly what I'm trying to prove. Angle ABC is going to be congruent to angle ACB. So let's go ahead and do the proof together, and let's see if we can kind of put it all together so it's well organized. All right, so here it is, the first part, and I think again, I keep making the mistakes of DAB, so let me go ahead and make that quick change just so that I don't embarrass myself. So that's going to be DAB changed to DBA, okay? So DBA for each one of these. So DBA, DBA, and I think that's all of them. So let me go ahead and write it in right now. So DBA, DBA, and then also DBA. Okay. All right, so let's see. Let's go ahead and begin. So first, I'm going to go ahead and start with the given, right? So DBA is congruent to DCA. So I guess you can see in the picture, those are going to be my X angles. If you want to sneak that in there and say that they're both equal to X, we can go ahead and do that. And over here, they're both equal to the Y according to the picture. So angle DBC is congruent to DCB then, okay? Next, once we say that they are congruent to each other, I want to start coming up with equations so I can relate all of them. So by using the definitions of congruence, I'm going to go ahead and say that their measurements are going to be the same as each other. So nothing has changed. All I did was I just changed the congruence into numerical measurements. Now, if you look at the order, DBA and DBC, that's the stuff that's in the red right there, right? You can add those two together to get this guy right here. And then this right here, you can see that DCA plus DCB, we are going to have this guy over here on the bottom. So what that means is we're adding to both sides a consistent amount because the top equation is the same and the second equation is the same, so we can add them together. So that right there is going to be called the addition property of equality. Careful, is not the same thing as angle addition postulates because yes, while we are adding angles together, we're adding equations that is equivalent to both sides. That's what we're actually doing from step 2 to step 3. Okay. Now that we've added them together, we get this really, really big mess. And here, now you'll notice in step 4, I say the measurement of ABC, ABC being, this whole thing right here, is equal to the measurement of DBA, okay, so DBA, plus the measurement of DBC, so that's a smaller piece. So here, this is going to be my angle addition postulate because I'm adding two angles together and claiming that it's going to be the result of the bigger angle. Okay, so that is the difference between step 3 and step 4. Again, addition property of equality, you add both sides consistently, but whereas angle addition postulate, you're saying that the sum of the two smaller angle makes up equal to the measurement of the bigger angle. Okay. All right, so hopefully this color coding is going to work out for you, because you can see now, if I say the black right here, which is this guy right here, is equal to this guy right here, and then if I say that dBA plus the measurement of dBC, right, is going to be equivalent to this guy right here, then there's going to be a bunch of transitivity property going on. So we're just going to cut out the middlemen, those two small, long equations, and make it into one simple one. So now we can say that the green, the measurement of ABC, is equal to the measurement of ACB by doing a transitive property, cutting out the middleman. Okay, so transitive property. And finally, that is basically what we're trying to prove. The two angles that we have are equal to each other. So then by definition of congruence, we can say that they are congruent to each other then. Okay. So it's sometimes, very, very nice to actually just kind of mark everything that you have right here, as you can see in the proof. So then that way you get a better idea as to how you're going to approach the proof, because you have to organize all your thoughts and put it all together. Okay, let's look at this last one right here. It's basically another proof, but it's the same idea over here. Okay, so we're given in this case angle 4 and angle 6 are going to be 180 degrees. You can say that they're supplement to each other, but either one. So that's going to be given. I want to prove that measurement of angle 5 is the same thing as measurement of angle 6. So here I want to prove that these two angles right here are equal to each other. So that's where I'm going to go ahead and put the question mark. All right, so let's go ahead and begin. Take the given right here. Now, there's not much you can do with this. Measurement of angle 4 plus measurement of angle 6 is equal to 180 degrees. That is literally a dead end. So what that means is we might want to dig around just to see what we can kind of unearth. So we can go ahead and use it with that measurement of angle 4 plus measurement of angle 6 is equal to 180 degrees. So all this in black here is basically what I noticed. 4 and 5 over here, they form a linear pair according to the picture. So I'm going to go ahead and extract as much information from that. So first we're going to say that 4 and 5 are a linear pair, or forms a linear pair, definition of linear pair. Next, I'm going to extract that they are supplement as we would normally, supplement postulate. And then afterwards, we're going to go ahead and say that the sum of those two angles would equal to 180 degrees, and that's by definition of supplementary. And right there, once we get to step 3, you can see that that is pretty much all we can get out of it. That's all we can extract. Hey, now we have something to play with, because if we take the given, right, now you'll see that it has 4 and 6 in there, which is nice because my equation that we just derived also contained the measurement of angle 4, and they're both equal to 180 degrees. So now I'm going to go ahead and take the given and write it out and set them equal to each other according to step 3 and also step 4. Because they're both equal to 180 degrees, then I can say the measurement of angle 4 plus the measurement of angle 6, which is over here, is equal to the measurement of angle 4 plus the measurement of angle 5, which is located right here. So that, once again, is going to be transitivity, and that's from step 3 and also step 4. Taking that equation that we have combining together, now we're going to go ahead and do some more algebra. Clean out the measurement of angle 4 they both have on both sides by subtraction, and now you have measurement of angle 6 is equal to measurement of angle 5. So the best way I can explain what you're doing in terms of proof, right, as a tactic, it's kind of like a jigsaw puzzle. What you want to do is you want to lay out all your pieces, and then you're trying to kind of combine as many of them together as possible. And from there, as soon as you say, okay, this is as much as I can do, now we're going to combine other informations together, so then that way we can link up and create new information. Okay, it's kind of like a little bit of alchemy, I guess you can say. Well, anyhow, hopefully that's an analogy that you can understand. I will see you next time.